church or mosque. These are all point features. Okay. Whereas a telephone line, that point. Whereas line means linear features. Linear features may be a drainage feature, a river, or a road. The road may be the national highway, or it may be state highway, or it may be village road. How we are going to differentiate this, that we will discuss. Then after that, polygon. Polygon may be, it is for the forest area, or it may be for the reservoir. So what do you mean by polygon? Three sides, it is a triangle. Rectangle, four sides, pentagon. If we have more number of sides, it is a polygon. Okay, number of sides. Then, how we are going to choose whether it is a point or line or a polygon? So the thing is, that depends on the scale which we have taken. India, if you have taken, okay, at the childhood you might have said, India map. In the India map, suppose you have taken Dhanbad, how it will be?
Point.
It is a point feature. Now you have taken the Jharkhand state. Then Jharkhand state you have chosen, and then you have taken the Dhanbad district. It will be a polygon. But Dhanbad city, it may be a point. Isn't it? Suppose you have taken the Dhanbad city map. In that, ISM may be a point. Okay. Whereas if you have chosen ISM, that map, in that it is a polygon, whereas the building may be a point. So point, polygon, that depends on the scale which you have chosen, right? Then about the linear feature. River is there, then you have a canal. What is the difference between these two? The river means it is a natural occurring stream. It doesn't have any control. If you have seen the satellite imagery also, it will be in a zigzag fashion. No control. Meandering. So in the earlier days they used to say the river, there is a flooding and then it has changed its course. Earlier the river is flowing there and now it is river is flowing here. Some of the times you can see that the river is there and bridge is constructed over the river, and after some flood or any other this catastrophic effect, it has changed its course. Now the bridge is useless because the river has changed its course. It may take 1 year, 2 years, or it may take 10,000 years also. Okay, then that is linear feature. What about the canal? Canal means artificially designed. You will not go for this much zigzag. So you will have a controlled direction. Whenever you are taking a turn also, train, whenever it is taking a turn, how it will take? Abruptly 90 degrees it will take, smooth curve it will go to take. Same with canal also. Okay. So there, in the satellite imagery, you can find out that, so this is a canal, this is a river. Then coming to polygon, the reservoir is there, the water body is there, forest area or built-up area, these are all polygons. Is it not? So point, line, polygons. Now in that I think you might have started stages. At the starting you will have only single color. Then if you are going for some different water samples, so what you can do is, there points you can digitize and then you can give the number, or you can change the symbology. Symbology means different colors also you can assign. And within the points also there may be category. So the point may be a tree, another point may be a building. How you can categorize in different symbology. Is it not? Okay. So this is all required for preparation of the maps. Now, what is the source? Okay, this is a video shooting, we are least bothered because of that Minister of Education, there is a live which is coming up. So these people are doing that. Earlier also in 2018, I have conducted one non-course. There we will shoot and after editing, it will be sent. But now live streaming is there. But your understanding of subject is more important. Have you seen the topo sheet? whatever that you are working, it is the topo sheet, is it not? Open. This is a topo sheet. Is it not? So, in the topo sheet, what are the features that you can see? What are the features you can see? Latitude, longitude, is it not? 5 by 5. 5 minutes by 5 minutes. It is now 15 minutes by 15 minutes. Okay, what is the scale? 1 is to 50,000. 1 is to 50,000. 1 centimeter on the map, 50,000 centimeter on the ground. Okay, now this is 15 by 15. This is 15 by 15. 78 degrees 15 to 78 degrees 30 minutes. 15 by 15, 5 minutes. In this, what are the things that you can see? The red line is there. This by experience I can tell that this is a road. If you are confused, already legend is there. What is this? River, dried up river. The green color, now actually it is a forest area. Okay, so here we have got the streams. Then settlements are there. We have the contours. Contours means imaginary line connecting the points of equal elevation. There may be ridge point, telephone line, railway line, what not. Everything is given here. Everything is given here. But what is the catch here? Why we are going for the satellite image? Why we cannot use this proportion? This is 1 is to 50,000. Suppose if you have a bigger area, 1 is to 250,000 satellite imagery or this proportion are also available. Here the thing is, you can see here is when it is prepared. Here the years will be when it is prepared, it will be there.
Upside, the left side of the corner next to the right side.
It is a 2011 edition, but it is prepared in carbon. No, that is different. This is a new thing happened. No, there is one. Yeah. इसका नीचे है. वो दोनों दे. Now the thing is, suppose you are doing analysis for your area. Your area falls here. Then what happens? If it falls here, it is within this topo sheet. If it falls here, then you have to purchase or get the map of this beside area. So this is T04 G8, center one. Left side, this is the one. This you have to procure. If it is on the top, this one. Corner, this one, like that. You have to procure. Okay. Now, actually, this is around. This is 56 L9. 56 L9 and then this is 56 L13. Two maps. Can you able to see this? The difference also, this is a little bit colored and this is black and white. What is happening? My study area is falling in the junction. Okay, just I have this. These are two topo sheets. This is 56 L by 9. This is 56 L by 30. 56 L by 30. Okay. So here you can see this is 56 L by 9 now. What is the adjacent one? 56 L by 30. That we have compute. Okay. Scan this. Just observe this. What are the features that you can see in the topo sheet? What are the features? Topo sheet means the road will be there, streams are there, forest area, everything, railway line, whatever way. Now, here you can see it is prepared in 1969. Okay, 1969. If you do any project by considering this, because the data is available, what happens? So there are lot of changes within few years. There are a lot of changes. Urbanization may happen, forest area may decrease, new reservoir may form, old reservoir can be, okay, it will be reduced in area. So many changes. So to go for what is that is happening on the ground, we are going to use the satellite images. Those satellite images, if you want to procure, you can procure from NRSA. These are from Survey of India. Survey of India is going to do this. Now this is one of the satellite imagery which I have procured at that time in way back 2009 for the same area. So here you can see this. Now this is satellite imagery. Lat logs, everything is given. But this is according to my requirement. Normally, if you get any satellite imagery, nothing will be there, just like this. It will be. I will be showing the pictures. You cannot identify anything. So for clarity, what I have done is, so here you can see, that's it. Same area. How you can identify this one? The road is passing. Is it not? So same area, there may be some changes. But this satellite imagery and topo sheet. So the topo sheet, that time it is hardly 5 rupees, 10 rupees. Now it is 100 rupees, and some of the topo sheets which are not problematic, they are available online. Whereas the satellite imagery, depending on when you are going to purchase, that time it is around 15,000. That is the cost. And depending on the resolution also. I think resolution you might have, okay, designed by lecturer of Professor. Is it not resolution? Okay, so for getting the latest information, satellite image. Then you can immediately ask Google that maps are available. I will also tell what are the latest. Okay, so satellite images, it is going to do the latest information, but nothing will be there. That by satellite imagery you have to choose, and by software you have to do the analysis. Now it is everybody can read, because the legend is available, you just read out that. But with the satellite imagery, it is directly we are going to get from the satellite with some rectification. Rectification means the earth is not square, it is a different ellipsoidal, and also it is rotating, the satellite is also rotating. So actually it is having some geometrical correction is required. Geometrically corrected satellite image we are going to get. So now we have understood now why the satellite image is required, and this one sheet. This is, you can get soft copy also at that time, CDs. Okay. Any one of you worked on floppies, earlier floppy, small thing will be there. Remote Sensing Agency, Department of Space. This Survey of India, it is under Ministry of Science and Technology. So this is Department of Space. What is the very first class I have shown the path now. So what is the path, what is the season? Suppose I have less resources. Now it is 2025. If I procure some 2020 image, the cost may reduce. Just like your Tatkal ticket. Okay, these are also, suppose you got some 2010 data which is available, that they will get a cheaper price. You got it? Now, are these two data only available? Any other data you can get from Survey of India or NATCO? Have you heard the name NATMO? National Atlantis Atlas Thematic Mapping Organization. Then you have GSI. Next. And one more thing, get the data. You have to go to the highest authority at Delhi. Okay. So this is one of the maps because I will show you. One of my scholar has done on Darjeeling. So Darjeeling, it has got boundaries, so Nepal and other things. Here, what is the thing that you are going to find? International boundary. Restricted. Here you can see restricted. So this map is restricted. So because he is working and on my letterhead, we have to write the letterhead. This is my responsibility. So the amount is not the huge amount, but availability is a big problem. Since he worked in Delhi Public Service Commission, he could be able to get the data by repeatedly going to the Surveyor of India. So there are some restricted maps. And because if you are going for any research, military camps or any strategic locations are there, you won't get data. Satellite image as well as this. Okay, so this type of maps are also available there. We have here it is written Nepal. Is it done? Now what are the other types of maps that are available? So same topo sheets, earlier one is there, now they are coming with new number and some of the things are already available in the net. These are all editions. If you see the textbook also, the first edition may be 1970s. After that, whatever the new book is, some these things, these are all editions. Okay. So now the maps are available like this. Okay. So this is regarding the Survey of India maps. What is this type of map? So here you can see for some limited districts. For some limited districts. So NATMO is another parallel organization, sister concern. Okay, Survey of India is there, NATMO is also there. So NATMO, they have published this. What is the significance? This is topo sheet, is it right? But what is the scale? What is the scale? 1:2 lakh 50,000. Entire district is there, 1:2 lakh 50,000 means 1 centimeter is 2 lakh 50,000 centimeters. So 2,500 meters or 2.5 kilometers. So 1 centimeter is 2.5 kilometers of the ground. Now, in this, what is the given? Here you can see the climatic conditions, then natural hazards, soils, what are the different types of soils available, rocks and minerals, relief and slope, irrigation, industries, general land use and traffic pattern, and population. These details are given. So in this, just by viewing this type of map, if somebody wants to go for any developmental activity or you want to go for any research, here basic information is available. What are the different types of soils? What are the different climatic conditions? What may be the rainfall? Here you can see the rainfall varies from high, it is 2,400 to 3,200. Rough estimate you can get. What are the different types of soils? Here it is given. What are the different types of soils? What are the different rocks? And what is the relief and slope? Entire thing is given. But the thing is, this is for entire district. You are going to do research projects. That is for a very limited area. Suppose somebody has given data of entire Jharkhand. Then Dhanbad, some of the important features you may be missing. Is it that? Because of the data, isn't it? So it gives an overall idea. These are all right. So these types of maps are available. So this is from not to for some limited districts. So this is for our Dhanbad. This is for our Dhanbad, which is famous for coal. So what is this entire bit? Entire bit. This is your area, all those regions where these are coal. Now, here population, industries, relief and slope, rocks and minerals. Rocks and minerals are there. And then soil, climatic condition, irrigation, land use land cover. In the land use land cover already it is given. Okay, this is. And our urban area is present here. Yes. So this is regarding Assam. For summary districts which are available, these are all the same data. Okay, by NAT. And some of these type of maps are also prepared by the Survey of India, which comes under Department of Science and Technology, DST, famously known as DST. Okay. Yes. Now, just see this there. What is the role of Geological Survey of India? District resource map. That is district planning map series. District resource map. So, district resource map, geology and minerals. This is for one part of raised water. And here, water shown is geology. What are the different types of rocks, minerals, strike, dip, geological features for this entire district. And here it is prepared by it is based on Survey of India proportion.
Lecture hall
But it is
fourth
prepared
floor
by
and fourth floor.
GSI, Geological Survey of India. It is in 1969. Okay. So, topo sheets and this will be matching, is it right? And then we have got all the information regarding the geology and minerals. Nowadays, this is most important, no? So, for getting the mineral resources. So, the topo sheets, if you can see, what you will get. Topo sheets will know superficial details. Whereas, if you go into the ground, these are the things which are available. Okay? Yes. Next, another map. हो रहा है? What is telling?
आगे नीचे में है।
नीचे में आने दीजिए, हो जाएगा। This is another one. District resource map. So there, here, what is the difference you are going to see? Geology and minerals are there. Geotechnical characteristics and natural hazards. And then soil varieties, geomorphology, geohydrology. So what are the various natural hazards? Because this obviously this P is also hazards. What are hazards? That's right. What do you mean by natural hazard? Natural hazard, this is the thing that will occur in the nature which we cannot avoid, but we can mitigate the effect. Flood is coming. Can you able to control the flood? No. So, but the effect of the flood on the human the resources that can be mitigated. Mitigated means we can avoid. We can avoid the losses. Flood, drought, then landslide. earthquake, forest fire, tsunami. Okay, all these things are the disasters. So disaster mapping is also there. Then maps will be taken here.
And the left three, left three. Left three, left three, left three. Three.
Area, yes. So this is our Dhanbad area. So earlier I have shown in the scale of 1:250,000. This is 1:50,000, and this is from the Dhanbad river. It's flowing, and this is the area, and after this area we will have so Mahanadi river basin, and then Krishna river basin, Ganga river basin. Because in the lab you are going to see the delineation and also after river basin. River and river basin are quite different. What is the difference between the river width may be 2 kilometers or 5 kilometers, whatever the water that is flowing. River basin means catchment area, drainage area of the river. So in that particular area, if there is any precipitation occurs to the network of the stream, the water will be coming into that particular river. So that is river basin. So here you can see this is our Ganga basin. You will have tributaries also. North is, what is this? Brahmaputra. If you come from bottom, Kaveri basin, then Krishna, Godavari, Mahanadi, like this. Okay, and all the streams of the sea. And I think you might have studied the stream order also. The bigger the stream order, more will be the runoff. Okay, first order stream, second order, third order, all those things. This is a they have published the results and runoff, rivers, and its runoff. So rivers are there. Earlier you have seen the river basins. This is rivers and runoff. Where how much runoff you can able to get. So here the estimate is there. Okay. Yes, next one. This is land use. I think you might have studied land use, land cover, how the land is being covered and how the land is being used. This is the true picture. So for entire India, if entire India we have got this map, what is the need of the study? The thing is here, they will be taking the portion of the resolution where the minute features will be missing. It gives a broad area, broad idea, okay, but the accuracy will be missing. If you want accuracy, you should go for 1:1000, 1:500. Then you will get the. Here you can see, this is natural hazards. So, what are the natural hazards? Just now I have told you. Heavy flood, drought, landslide, earthquake, all those things. But what if there is any natural hazard which is occurring simultaneously? Means earthquake is there. Earthquake, it occurs in the hilly area. What happens? It will trigger the landslide. If rainfall also occurs, so that is a perfect situation for this landslide. Okay, so similarly drought, forest fire. Like in India, what are the various natural hazards? We have mapped. Okay, so earthquake prozones, earthquake, then you have here in the coastal region. What we can expect? Okay, flooding also you can expect and also surely, but most commonly flooding, is it not? During your the monsoon season, very 15 to 20 days, once you can expect the low-lying area in the Bay of Bengal, which will convert it into monsoon and then you will get the heavy rainfall, is it not? So, the depression will be created and then, so that's why in the coastal region you have got the hazard of floods. Similarly, on the hilly areas, landslide will be there and near to Nepal you have that northeastern earthquake, all those things are given. Okay, it is already mapped. Yes. Huh? The geology, yes. This is for entire India. The geology map. What are the various geological formations here? So now in some of the sites it is freely available also, but the thing is you have to, whenever you are doing any research work or any work, you have to cite the source. Okay, cite the source. Here it is Survey of India. Okay. Everybody may be aware of that. Rabi season, Kharif season, okay. After the monsoon, whatever you are going to, okay, in the crops, that is called as Kharif. And there you have got the Rabi. Kharif, Rabi, so for around 4 months, then there are some crops which require water continuously throughout the year, like sugar cane. Sugar cane is a perennial crop, okay, like this. So, what are the different crops and crop regions? This map is showing like this. So, in India, after Jaisalmer, this Anantapur is the drought prone because it is in the west, leeward side and you have got windward side, no? It is in the leeward side. Yes, yes. So, the research work, the main things are delineation of groundwater potential zones and water quality index. So, I have not explained on the research work, I am just want to show you what are the different maps and symbols. Yes, next. So, as already told you, it is a drought prone area and then the rainfall is 50 centimeters. What is the average rainfall in India? It is around 119 centimeters. But it is hardly 50 centimeters rainfall. So, there are no major rivers, so drought conditions are prevalent. Yes. So here you can see what you have observed. India has got India map on scale and within that Andhra is marked. Even within the Andhra you have got the Anantapur which is marked in the red color. Okay. This portion is having one scale. And then here Andhra Pradesh is highlighted and you can see a bigger map of Anantapur district. And within that there is a small thing. What is that? This particular Kadri region. Okay, this is another scale. And then now this Kadri is highlighted, Kadri basin, and this is the map. What are the various features that you are seeing there? A linear feature is there, polygons are there, point I will show you. Okay, so in that stream is there, some river bodies are there, and the forest area is there. How I can know? Is there given legend. Okay. And what are the other observations you can see in the map, anyone of you? Those who are starting, already some of the people, they may be knowing this. What are the other things? You are experiencing different features like scale is there, and north arrow is there, title is there, and latitude longitude. These are all very, very important for any map. You create the map. While you are studying the point, line and your polygon, after that you are going to distance and create one map. And in that map, you are going to give it to some other people. Then what is the direction? what is the scale? So here it is mentioned, this is the scale, and that is the north direction. And once you know the north direction, obviously all four directions will be known to the east, and latitude, longitude is also very important. I think you might have seen the georeferencing. If it is not georeferencing, okay, you cannot able to get that question. Next. So this is the methodology which we have followed. Next. Yes, next. Groundwater potential zones. Next. Means what? Groundwater potential zones means by using the remote sensing and GIS, without going onto the ground, we can tell that here the groundwater may occur. Note on the line may. So how you can know that? Very scientifically by getting the topo sheet and then satellite image. So if you have studied the hydrology, then it is mentioned. Suppose soil is there, clayey soil is there, sandy soil is there. Infiltration, because that will be reaching the ground. Whenever precipitation occurs, there are various things. What are the evaporation? Then you have got the runoff, transpiration, then there will be infiltration, all those things, some percolation. The deep percolation and infiltration, it reaches the groundwater. So the thing is, infiltration should be more when compared to the runoff. So infiltration should be more means what may be the type of soil. Clayey soil, infiltration is less. Sandy soil or gravel, okay, you will have the more infiltration, right? Then slope. If it is a flatter ground or less slope, the water can infiltrate. If it is a steep slope, the water will run away. Runoff will be more. Okay, so yes, that is one. Then more the precipitation, more will be the infiltration. Then what are the other things? Land use, land cover. If it is already covered with some bigger trees, the infiltration will be less. Whereas if it is covered with the smaller bushes, all those things, the water will infiltrate. If it is a paved structure, means suppose building or roads are there, water will not infiltrate. If it is a barren land, water will infiltrate. Like that, we have geology. If it is a granite, water will not infiltrate. Though that may be very much significant for building construction. But for water storage, granite means it is a solid rock. Whereas if you have limestone, sandy stuff, there may be some porous which are there, so that water can infiltrate. Okay. If you see gravel and sand bed, you should be happy because it is an aquifer. Water is available. Like that, here in this geology, geomorphology, soil drainage density, like that we have taken. So what is the significance of this? The weightage means within these various themes. What do you mean by thematic map? Now every time I will be using the map, thematic map. All the features are available. If we are only mapping the geological aspect, it is called geology map. If I am mapping only soil, it is soil map. If I am mapping slope, slope map. Then how I am going to do the weightage for this? This I will explain with a small example. India, we have got different states. Normally, truly speaking, all are one and the same. But if we have some elections or any other thing, which is the most important state, which is the decisive thing? UP. Isn't that because it has got more seats, whereas smaller states like Pondicherry, Goa, very less seats are available. Is it not? Similarly, all are one and the same, but weightage. Similarly, here also, all features are there, but geology plays a major role. Okay, whereas land is land cover. Lesser, like this. That is called weightage. And within that also slope is there. In the slope, steep slope, less possibility of infiltration. Whereas flat slope, more infiltration. So there also we are going to give the weightage, but here technically we are going to give the name as rating. Both weightages will be confusing. So first one is weightage, second one is rating. Okay, like this we are going to give the rating and the weightage next. Then These are the various schematic maps. So this is the standard image, and then this is aspect map. Let's go next. Then geology map. Geology map means it contains only the geological features. But you can see the shape are same, is it not? Then what are the other features which are same? Latitude, longitude is there. Then you have north arrow and you have got the legend scale. So these are all essential features of any map. Okay, next. Slope. Then you have got rainfall map. Next. Geomorphology, soil type. Next. Land is land cover, soil type. Here, go to the previous slide. Here, if you see the soil type, what are the various features available? Are there any points? Are there any linear features? Only polygons are available. Is it right? Yes. Next. Now you see the land is land cover. Can you see the drain? It is a linear feature, is it not? Then you have got some points also, and then you have got polygons. All three are present. Next. Yes. Next. Then is this. Finally, this is the one. Clubbing all the things. I have understood what is overlay. Overlay. One above other. One above other. All the things. Just like a sandwich. Different layers. Okay. So now what is the inference of this? All good features means, just I am telling as an example, if it is a sandy soil, if it has got lesser slope, if it has a heavy rainfall, if it has land is land cover, which is a barren land, you would have less vegetation, all these features, they will be getting you good groundwater. Whereas the reverse, if it is steep slope, lesser rainfall, if it is a gravel, not gravel, if it is a clay soil, if it is a granite, there is a less chance. So if you are going for any bore well, a bigger area is there, because groundwater, here you will get the groundwater. If I am going for a bore well within some 10 meters, can you assure that groundwater you can get? So in between there may be dike, you cannot able to get the groundwater because groundwater is flowing. So, but boring is a costly affair. So by seeing this map, what you have done? Have you gone to the site? No. You acquired topo sheet, you acquired satellite image, you done some research and given the weightages by field experience and also by literature and by your own experience. Now, what is the inference of this? The green color and blue color, there you can get groundwater. You may, I am telling these words. Whereas the red one, you may not get. So why you are going to experience there by drilling the bore well, whereas you have this area? Is it not? Then what is the thing? Next you have to go for the next level, that is geophysical investigation. You have chosen a point in the blue or green color and then go for geophysical investigation. That also you need not have to dug the soil. So there resistivity meter, resistivity survey is there, then you have magnetic survey, then you have seismic survey, okay. Then you are going to pass the current, you are going to pass the velocity by using the seismometer, electromagnetic, you are going to send, and magnetic field you are going to test. If there is any change, that can be recorded and you can able to identify that there is an anomaly. And again, how I will get the accurate thing? By boring only. But the thing is, you are delineating, you are separating good zones from the bad zones. Okay? Right? So this is one of the objectives. Next. So the area is very good and good. It forms normally 45%, whereas 55% is poor and very poor. It comes to around 25%. And moderate also can take it. So 45% of the area only you can get the water. Okay, next. What is the other thing? Water quality. Water quality. If you get abundant water, but the water quality is poor, then can you able to use that for drinking? Mainly, we are focusing on drinking. You can tell that water can be used for car wash. Okay, that is accepted, but mainly focus is on drinking. From here, 20 kilometers away, you have a village called Garbar and Bariapur area, where the fluoride is around 18 to 20, whereas normal up to the standard, the fluoride should be from 1 to 1.5. If it is more than 1.5, 3 up to 3, you will have dental fluorosis. So, okay, then if it is more than that, you will have skeletal fluorosis. So, if it is 5 or 6 also, you can get the skeletal fluorosis. Skeletal fluorosis means the bones will be crippled. The 50 years person will look like a 9 years boy. Okay, it is not fit for anything. Like that. So much the problem is there. Okay, if you have abundant water, can you use for drinking? No. You can use for some other purpose. Okay, after treatment. Now, yes, next. Here, overweight data and then deadweight data. We have from you next. Next. Yes. But as you can see the dryness, because it is on the leeward side, very less rainfall. Normally you see any hill, you will have some vegetation. Too dry. Yes. Borders. Next. Yes. What is this? So in this area, how many samples you have collected? What is the number? 70? 76 also you can see. 75, 77 samples. Whatever the groundwater data you have collected, you have analysis, okay? You have analysis for the different parameters for drinking pH, alkalinity, chloride, fluoride, nitrate, sulfate, okay? So all those things, iron, and then you have heavy metals as well, fluoride, and also the lead. And then, what are these things? This is the location. And the good thing with this GIS is, if this is not there, what you have to show? You have to show a boring tabular form. Tabular form, latitude, longitude, and then pH, number 1. This is the village name like this. So there is the same data that is called, this is spatial, that is called attribute data, which will be behind. Attribute data, from that you are going to get this. What I can show, if I want to show the number, I can display the number, or I can remove the number and only I can show the points. I can show different types of points, colors also I can vary. Now, if I want, what is this 47? I want the name of the villages. I can display this also, but here you can see this one is not. Okay, there you can show the number and then you can do the list. So this is, what is this? How many maps are there present here? What is the data? One is polygon, which is covering the entire, polygon is there, no? Because the Valley watershed, entire thing is I have shown as a polygon. Then water is there and then groundwater samples. Okay, next. Yes, theoretical conductivity, pH. For each parameter you have the data. More the data, more will be accurate. So, in GIS we have the IDW. If we have few points, the in between points, it will calculate and it will give the data. Somewhere it is 50, other way it is 40. So in between 45. So it will do that. But the thing is, more the points, more will do the accuracy. Yes. Hardness, magnesium. Next. By seeing itself, you can tell by legend. Okay, this area is having less chloride. This area is having more chloride. Like that. Yes. Calcium, iron. Yes. Potassium, nitrate. TDS. If nitrate is more, you have Villuri syndrome. If arsenic is more in this part, you have different types. Okay, all you have got GNSS next. Finally, this is fluoride. What you can observe? 0 to 1 is blue, and then 1 to 1.5, which is the safe limit, is only green. remaining portion, red you can see it is more than 3.5, red zone, which is occupying a more area. Next. So villages, next. Yes, this is the data. This data we are represented in a pictorial format. Normally when you see get the data, it will be like this, tabular form. This data you are going to call it as, what we are going to call it as, this is non-spatial data or attribute data. With this, we are going to create the maps, which is called spatial data. These two have got some relation. Okay, if you change this, automatically the value also changes. These two are related. Next, sample points and the groundwater quality index map. Groundwater quality index. What do you mean by this? Suppose a layman asks, can I be able to drink this water or not? What you will reply? pH is some 10, chloride is 20, nitrate is 5, fluoride is 3.5. He doesn't want all these things. What he want? This water can I able to drink or not? So that for that we have got water quality index, which I have shown the calculations in here. Okay. So water quality index, if it is in between this range, we can able to take. That is potable water. Excellent water, good water, moderate, poor, very poor, unfit for drinking. Some categorization. Okay. So that if it falls here, what is the difference? This region, red region, the water, it is unfit for drinking. You go to Bariapur, there some of the borewells, it is marked with red color. So this is not fit for drinking. Borewells. Okay? But if you want to pour that water in the car and you want all those other uses that you can use, but drinking is not useful. Yes, the next one, that greater than 100, which is unfit for drinking, whereas fit for drinking, 2.58 is very less. Next. Yes, next. Water quality index or next. Similarly, whether this water can be used for irrigation or not. Again, we have calculated various indices, and then so here also this poor, good, excellent. Now the area has slightly increased. Okay. Yes. So next. So how to reduce this? We are working on this by using absorption. Next. By using ultrasound, we can able to reduce whatever the impurities are there. Next. More. Next. So by using this natural occurring material also, we can reduce the natural occurring. There are some chemical products also that we can use. Yes, next. Here you can see dental. So he's not a boy, okay? Also, but you can see here. Okay, next. So last slide I want. Yes. Like this. Here you can go for that rice has under different layers, so that water which is available will be filtered, and then after that you can be able to supply. Okay, this is just close. And in further classes, I will show some of the other aspects of GIS, and then I will show some of the case studies as well, which my scholars have done. Right? Now, have you got the clarity of point line and these things? And one more thing about this is, which scale I have to take. Suppose satellite image topo sheet is fixed, no? Whether I have to take 1:50,000, 1:10,000, 1:2 lakh 50,000, how I will know? You are working on entire Ganga basin. How there is a change in the that riding and what is that? It is meandering occurs. Meandering. Then you cannot take a simple 1:50,000 and small area. Then you have to take a broader one. Okay, because 2-3 scenes you should cover this. Suppose you are working on how the city is changing. Then if you have taken that much scale data, that your city may be a point data that you cannot. So there you have to use another scale where you can able to see the city and also environment. Okay, so how I can know that the city is expanding or less? You go for this urbanization and then decrease of your land. Urbanization and deforestation, both are one and the same. So you choose some 30-40 years of data. 1980, you get one satellite image. 1990, 2000, 2010, 2020. 5 years data. You prepare the map. Obviously, there will be urbanization, there will be decrease in the forestry. Okay, so like this. So depending on your study, you have to choose the data. And in next class, I will be showing. Already Google data is available free of cost. Why you have to purchase this data? Okay. Yes. Any questions? Okay, we'll close.